Okay, integration by parts. Integration by parts, sorry. As you may remember from the differential calculus, that the derivative of, suppose u and v to be functions of x, and from the differential calculus, the derivative of their product, equals to the derivative of u times v plus u times the derivative of v. Okay, now let's integrate both sides. That tell us that the derivative of uv dx equals to the derivative of, the integral of this would be equal to the integral of u prime v dx plus the integral of u v prime dx. Okay, now this equals to the differential of uv, and this du prime times dx equals to the differential of u, so that would be v du, and this one v prime dx is the differential of v, so that would be u dv. Now this is, let's call it h. Okay, this is the integral of dh, which is h itself. Okay, and substitute uv into h. This is uv equals to the integral of v du plus the integral of u dv. So that tells us that the integral of v du equals to uv minus the integral of, this time, u dv. Okay, this is integration by parts. So let's see how we could calculate integral using that. Suppose this x cosine x dx. Now, by the previous methods, we could not calculate it. So how about this? This is, this is the derivative of sine of x. So let's write it this way, equals to x, the derivative of sine of x dx. So this would be, this would be x d sine of x. So here the v equals to x and u equals to sine of x. So that would be x sine of x u times v minus the integral of sine of x dx. You know, v was x and u was sine of x. So easy peasy. That would be x sine of x minus the integral of this, which is minus cosine of x. You know, that would be plus cosine of x. And some constant number later. Okay, let's do another example. How about this? X squared e to the power of x dx. Again here, this is the derivative of itself. I talked about it before that the only function which derivative is itself is e to the power of x plus c. Okay, so let's write it. X squared, the derivative of e to the power of x dx, and this is the differential of e to the power of x. So the differential of e to the power of x. Now here our v is x squared and our u is e to the power of x. So that would be equal to x squared times e to the power of x minus u was e to the power of x and v was x squared dx squared. Now we're not done yet. Now what is it? It is e to the power of x. This is the derivative of this, which is 2x dx. So take 2 outside. This would be this. e to the power of x dx. Now again, this is the derivative of itself times dx would be the differential of itself. Let's say x differential of e to the power of x. So again, for this integral, v is x and u is e to the power of x. So this would be equal to x e to the power of x minus e to the power of x dx, which is our v. So this is e to the power of x plus some constant. So it should be multiplied by 2. I forgot that, okay. And this was this, okay. So we should subtract it by it. Okay, the power of x minus 2 e to the power of x minus 2c, or let's call it c prime, which is our constant. So that's it.